Now the next algorithm is sorted seek time first. As per name implies, it satisfies the request according to the seek time. How we will identify the seek time? The seek time is the time taken by the head for movement from one track to another track. So we have to identify the nearest track from the current position every time there is a task to identify the nearest one. The track request, the request is already available in the queue. From this queue, rather than satisfying as they appeared in previous method, that is first come first serve, in SSTF, that is shortest seek time first, we every time we have to identify which one is nearest from current track position. The head is satisfying at particular track, so we have to identify next track which is nearest from the current track. So again we have given a queue 86, 147, 91, 177, 94, 150, 102, 175 and 130. As we have solved this problem, we have seen that how first come first serve has solved this problem, has satisfied this request. Now let us satisfy this request by using SSTF, that is shortest seek time first. I have already drawn the moment, the head moments. Again, we know that the current track position is 143, total number of tracks are 200, 0 to 199. Previously, it has satisfied the request at 125. So, we have to start with current track position, that is 143. Now, rather than starting with the 86, which is first appeared in the queue, we have to identify the request which is nearest from current track position. The current track position is 143. So we see that 147 is nearest from 143 because only 4 track has to cover to reach this track, requested track, that is 147. So we will start from 143 and we move up to 147. Then after, when we are satisfying the request at 147, it will identify the next track which is nearest from this 147. So next track is 150. Next request is satisfied is 150. Now after we see that there is a request, after forward, when we are moving forward, we see that 175 is also nearby 150. But we have to check whether is any other track request is there which is nearby. If it is shorter than this distance, that is 175. So next is 130. As compared to 130, 150 to 130, there is difference of 20 tracks, and here from 150 to 125, it is difference of total 25 tracks. So it is better to take the shortest one. We will take the 130 because it is shorter than 175. So 150 to 130. Then when we have satisfied the request, we will go to 102 because it is near. Because if we move backward to 175, it is too far as compared to 102. So we will satisfy the request as 102. Then after 94, 91, 86. Now once we have reached the 86, no further request is available this way. After 86, we are having all the requests. If we see here, the requests are 86, 147, 91, 94, 150, 102, 130 are all already covered. So remaining requests are 175 and 177. So we will go from 86 to 177 because when we compare this 175 and 177, 175 is nearer, shorter. So we will go to 175. Then only one request is remaining and it is close to the 175, so we will satisfy this request 177. Here also the total track moments are 9. Let us count 1, 2, 3, 4, 5, 6, 7, 8, 9. Like previously in first come first serve, there was also 9 moments. Here also 9 moments are there. Now let us count the total head moment. How we used to count the total head moment? That is difference between these two tracks. Moment, we have to write moment like 143 to 147. Next is 147 to 150 And when we have to calculate, we have to take the bigger number and we have to subtract the smaller number with this bigger number. So we have done here 147, we have subtracted 143 from 147, 147 from 150, 130 from 150. So we have calculated all this 9, 1, 2, 3, 4, 5, 6, 7, 8, 9. For this 1, 2, 3, 4, 5, 6, 7, 8, 9. We have written. Now when we have calculated, we get 4, 3, 20, 28, 8, 3, 5, 89 and 2. When we sum all this, we will get 162. Now the average head moment, total number of head moment divided by total moments. Total number of tracks covered are 162. To satisfy all this request is 162, and we have done total 9 moments. Starting from year to year, it is counted 1, so it is 9. Dividing 162 by 9, so average head moment is 18. Now let us compare it with previous example, FCFS. We have solved for FCFS. The total head moment was 565 and the average was 62.77 cylinders or the tracks. So here we can conclude that shortest seek time first used to give us better result as compared to the first come first serve. If we see various advantages and disadvantages of this algorithm, first start with shortest seek time first. We say that advantage is seek time is less. First advantage. Second advantage that it is better, the efficiency will increase. But there are several disadvantages that every time there is an overhead to identify the nearest one. Every time the system has to work to identify which one is nearest. As compared to previous algorithm, that is first come first serve, it has simplest mechanism that the requester came, the queue is already made, so we have to satisfy the request according to the queue. But here we have to satisfy the request as per the shortest distance from the current track. Second, if we go for disadvantage, we have seen that there is a bigger disadvantage that every time we have to calculate the distance, the upcoming request, which one is nearest one. There is a problem, but actually when we see it provides us efficient result. But in first come first serve, it deals with inconsistency. Rather than inconsistency, we will refer that inefficient because it gives the total head moment are very high. So it takes too much time to reach from one track to another track, because if the next track is nearer, then also we have to satisfy the track which appears first, which came first. So it is better to use SSTF in place of first come first serve.